guys, and welcome back to lesson 1.2 based on Earth's interior structure. Now in your notes I want you to pop over as far as page number 4, which looks like this. So this page here you're going to get over as far as, and we're going to get started. So the first thing I want you to do on this page here is, besides Earth's interior structure, anywhere on the top of the page I want you to place down just on the top of the page SQ for short question / part A. Now everything we're doing in lesson 1.2 is going to be for the purposes of short questions and part A's. They may blend into essays, but we're purposefully doing it for this. Now in relation to your short questions, just a little reminder, you have to answer 10 out of 12 short questions, 8 marks each, 80 marks in total. My best tip is do them all, and all that happens is your best 10 is chosen by the assessor. In relation to part A's are worth 20 marks and allocated 5 to 7 minutes of your time. Now let's get started with Earth's interior structure. Now the first thing you're going to see here is you're going to see your image of the structure you would have got at junior cert or junior cycle. Now in relation to this structure here, what do we have? This is the junior cert or junior cycle labels that we see here. The outmost layer here is referred to as the crust. Right below the crust, your largest layer here is referred to as the mantle. And finally, you have your core. You have both the outer and the inner core. Now, despite us seeing this since maybe first or second or third year, this actually does appear as part of the Cert questions as well. And I just want you to make a very, very quick note to the left or the right hand side where this has actually appeared. Because this actually appeared in short questions. Make a little note for yourself. It's appeared in short questions in 2022, in 2011 and 2007. So let's pop that down just so we can reference them. Again, all the short questions are at the back of our notes based on each topic. It has also appeared in part A's as well. We've seen it in 2018, as part of question number 2A, and we also seen it in 2014 as part of question 2A. Now you might pause the video for a second and actually pop back over as far as maybe page 48 and you'll see your short questions there. A little bit further on you'll see your part A's. However, they generally have a little bit more complex information. So guys, let's get started here with our first layer. Let's dive deep into this. Our first layer, we're going to start with the outmost layer, the crust. Now I want you to highlight the crust there on that page. The crust is the outmost layer, and there's two different types of crust. You have number 1, continental crust, and number 2, you have oceanic crust. Now highlight the word continental crust, and to the left hand side there, I want you to write down 2 words. In relation to continental crust, there's 2 characteristics I want you to remember, these 2 words. Continental crust is thick and light. Write that to the left hand side of number 1 there, the continental crust. Continental crust is thick and light. Now highlight the word thick. Continental crust is thick, usually about 30 to 70 kilometers in depth. The rock that composes continental crust, what we know is younger and lighter. Highlight the words younger and lighter there for me. It usually is a rock, something like the igneous rock, granite. The term seal applies. This rock is rich in silica and aluminium, and that term seal applies. Now when you look for continental crust, for instance, on your exam paper, in a diagram, what are you looking for? Well, let me just pop up here your screen. When you're looking for this continental crust here, you're actually looking for the crust that's in blue. Apologies, I'm going to repeat myself. You're looking for the crust that's in green, continental crust, green for land. I was concentrating on my pen there. Now, as I said before, maybe 2 things to write down on this crust would be that it's thick and light. Now, why I'm asking you to write them 2 words down is because later on, when we particularly get to destructive plate boundaries, we're going to reference that quite a lot. Now below your continental crust, you have oceanic crust. To the left-hand side of the word oceanic crust, what I want you to write down is I want you to write down thin and dense, or maybe thin and heavy. The oceanic crust is thin, usually between about 3 and 10 kilometers in width. And the rock that composes oceanic crust is older and denser. Highlight them 2 words for me, older and denser. It's usually something like basalt. Now, just in case you don't understand that word denser, what do we mean by the word denser? Denser just means heavier. The term SEMA applies. This rock is rich in silica and magnesium. Now, again, on your diagram, what are you actually going to be looking for? You're going to be looking for blue. Think about blue oceanic crust. In relation to this here, and just to pop back over as far as our table here, when we're looking for this on our map or in a diagram, we're looking for this blue crust that's here. I'll just mark off a tiny little section of it. And again, what is the characteristics of this? Well, it's thin and dense. Again, I'm just scribbling them down here, having them words available whenever I need them. So guys, moving across over to the next page, page number 5, we're going to look at the mantle. Now you should be seeing a page that looks like this here for page number 5. So let's get started. Now, in relation to my next layer here, this is where a lot of the complexities come in and a lot of the new information that we would not have seen for junior cert. It's in the mantle. Now, on the top of page number 5, you're going to see the word mantle. My mantle, you'll see we have labeled over here. Now, the mantle is the thickest layer. It makes up about 75%, I should say, about 70 to 75% of the Earth's interior. And it's split into 3 sections. Now, these sections are number 1, the highlight upper section. The upper section, which is highlighted the word solid. It is solid rock or it's very rigid. And here what we know is that the crust and the upper mantle combined is referred to as the lithosphere. Now, I want you to highlight the word lithosphere, and above the word lithosphere, I want you to write down 2023 SQ. Now, just on my diagram, let's mark that down. So we're saying this section of the crust here, all of the crust, and the top part of the mantle, which is here. And again, just in the mantle, what I might do is pop down a little convection current, which we'll speak about in a second, just so you can see it nice and clearly. Again, them circular movements of magma in the mantle. This crust and this upper mantle combined is referred to as our lithosphere. So it's solid, it's actually the part of the crust that we're walking on, it's your plates. And what we know is that this word, it actually has appeared a number of times, but most specifically in the 2023 short questions. We'll have a glance at these a little bit later on. Now, just below your lithosphere, that solid layer, and again, highlight that word solid, is the MOHO discontinuity. Now, the word MOHO was accepted in 2023 in the state exams. 2023 in the state exams. And basically what that is the MOHO discontinuity is a boundary. Highlight MOHO and highlight boundary. It's a boundary that divides the crust and the upper mantle. So just going a little bit further and back here, this boundary here between my crust and the upper mantle is referred to as my MOHO. So this here. So it's not a layer, the MOHO is actually a boundary. Now, MOHO discontinuity is the best thing for you to say, but this did appear a couple of times. It's actually appeared a number of times in part A's and also in short questions. For instance, we have it in 2022 in question number 3A. There they asked you the type of question like name the boundary. We also seen it in 2018 in question number 2A. Make sure you're making notes of these because basically what you want to do is refer back to them every single time. The last part here is, before we get obviously to the upper mantle, lower mantle. So the last part here, as I said, or second last, as I should have said, is the asthenosphere. Now, the asthenosphere is the semi-molten part of the mantle, or I should say the upper mantle realistically. And where it actually lies, it's very, very clear here. I'm going to mark it off in black, is just below the lithosphere. And that's a really good thing to remember for short questions. So just below your lithosphere, you have this layer here, and this layer here is referred to as my asthenosphere. A lot of students ask me, Tracy, do I have to get the spelling of this exact? No, it's not a spelling contest. You'll see once the examiner knows what you're talking about, they know what you're speaking about, and you know the answer, they're happy, so don't be worried about the spelling. Usually as well, they give you these words and what you have to do is actually label them. Again, we'll see that a little bit later on. The last layer here is the lower mantle. And the lower mantle, I want you to highlight lower mantle, just like you did for asthenosphere, is composed of molten material. So it's liquid-like. And it's the hottest part of the mantle. It's where convection currents. Now, convection currents, highlight the words convection currents. These are my convection currents here in the mantle, or this is my label for them. Now, highlight the word convection currents, and I want you to make a note for yourself. The circular movement of magma in the mantle. Let me repeat. The circular movement of magma in the mantle. Convection currents are the circular movement of magma in the mantle. And basically, the heat from the Earth's core generates these convection currents. The magma rises up. As it cools right along the crust, it falls again. And you get this circular motion. You'll see in questions like the 2018 Part A, they asked you how plates move. Plates move as a result of convection currents, the circular movement of magma in the mantle, dragging the plates sitting on top. Now that there is obviously my mantle, and that's actually probably one of the questions where the examiner asks you the most question. They tend to repeat the questions quite a lot. But before I move on to the core, one thing to mention, and one question they actually seem to love lately, is they love the word endogenic forces. And just to point out there, under the word convection current, I want you to write down endogenic force. Convection current is an example of an endogenic force. They asked this in 2018 and they also asked it in 2022 in short questions. They said, what is endogenic forces, or briefly explain. Endogenic forces are forces that act inside the Earth, and convection currents, which act inside the Earth, is an example of an endogenic force. Now that there is the mantle, let's move on to the core. So back on page number 5, on the bottom of this page here, we're going to move on to the core. Now, what we know about the core itself is that the core is the center of the Earth. So it's the very, very center of the Earth here. And basically it's composed of two things, iron and nickel. Now, I want you to highlight them two words, iron and nickel, and I'm actually going to bracket off my outer and inner core here. And the reason I'm doing this is because in 2014, in question number 2A, your examiner asked you to name two components or two minerals that's found in the core. They didn't specify inner and outer core because both is the same. So when I'm looking at both of these, I'm just going to make a little note of my 2014 question. And I'm just going to write down the words iron and nickel. Again, everything we need really is on the board here, all my major details. Now, what's the difference between the inner and the outer core? Let's start with the outer. The outer core is composed of hot liquid. Now, I want you to highlight outer and I want you to highlight liquid. So it's not solid. Think about it, it touches the mantle, so it's a similar texture composition, I should say, to the mantle. The highlight inner core. The inner core just below that is made up of solid rock. So inner, solid. So if I asked you, for instance, and I personally would ask this if this came up in the Leaving Cert exam, what is the difference? I said solid rock there, just to repeat, solid iron and nickel, apologies. The inner core in this case here, the inner core is solid, okay? Think about the inside of anything should be solid. If I was the examiner, what I would do is I'd ask you the difference between the composition of the inner and the outer core. I would say both are made up of iron and nickel. However, the inner core is solid, whereas the outer core is liquid. And again, both composed of iron and nickel. Now, guys, that is the composition of Earth's interior structure. And there's multiple questions if you want to pop over as far as page number 48, short questions, and a little further on, your part A's that you can get practicing. But I will be doing them with you in a later lesson. Guys, thank you very much. That is Earth's interior structure.